All right, we're going to go ahead and get started for our week 2 Zoom session. This week we're going to take a look at chapters 10 and 11. We'll look at rational numbers as well as begin some algebra problems. So we'll just jump right on in there. In this first example, and by the way, these are coming from our end of the chapter reviews. These are some good questions that will be similar to the problems that you see on your apply this week. So I've just pulled those from chapters 10 and 11, end of the chapter reviews. So in the first problem, we are asked to find the opposite. The opposite of a positive 22 would then be a negative 22. Okay. And the opposite of a negative 4 would be a positive 4. Now, if you don't see a sign, it's understood to be a positive. You do not have to put that positive sign because it's understood to be a positive. But if you intend for it to be a negative, you will need to put that sign in front. So the opposite of a positive is a negative. The opposite of a negative is a positive. All right. So in this next problem, we are subtracting integers, and our rule for subtracting integers is adding the opposite. So you'll do the additive inverse. So negative 8 minus negative 2 is actually the same as adding a positive 2. And for a problem like this, we're just with addition and subtraction, we just work left to right using the order of operations. When I'm adding numbers that have different signs, we actually will subtract those numbers and take the sign of the larger number. Just think of 8 as being more than 2, so the answer gets the negative sign. And then I'm going to bring down the rest of that problem, minus negative 10, so we'll do that again. I'm going to add the opposite, negative 6 plus 10. The signs are different, so you subtract and take the sign of the higher number, so that would be a positive 4. Okay. And then I've got that minus 3. So 4 take away 3 would equal 1 in the end. So just take your time when you're subtracting numbers. It's the same as adding the opposite. The opposite of a negative 2 would be a positive 2. All right. Here we're subtracting numbers. Remember that you have to find a common denominator before you can subtract fractions. The least common multiple between 8 and 6 would be 24. So I'm going to find an equivalent fraction. If 8 times 3 is 24, then 5 times 3 would be 15. If 6 times 4 is 24, then 5 times 4 would be 20. So notice here I'm subtracting more than what I have, and so that's when we get into these negative numbers. 15 minus 20 would be a negative 5, and remember that denominator stays the same when we subtract. All right, so number 4, we're adding and subtracting still, adding and subtracting positive, negative numbers. This, we're just going to work left to right. So I've got a negative 33 hundredths and 1 and 98 hundredths. So the signs are different, so we actually will have to subtract those numbers. Okay, and 1.98 is bigger, so the sign will be positive. And then I'm going to take 1.65 and subtract 1.44 from that. Okay, and my answer would be 21 hundredths. Of course, if you've got a calculator, that would be really easy to put in the calculator. Just pay attention to the fact that that's a negative, and that's not the same as a minus sign. So if you're inputting that in your calculator, you'll want to use the appropriate sign from your calculator. When we multiply with fractions, you may want to reduce diagonally first. 3 will go into itself one time, and 3 goes into 6 twice. 11 will go into itself and 22 two times. We can reduce diagonally or up and down, but you cannot reduce side to side. So this looks like all that I'm able to do. So on top, I've got a negative 2 times negative 2. When you are multiplying and you have an even amount of negatives, then that will always become a positive number. But if you're multiplying an odd number of negatives, that will, an odd number of negatives multiplied together will stay negative. So here I've got 2 negative signs. A negative times a negative becomes a positive. 2 times 2 times 2 is 8. And on the bottom, we've got 1 times 1 times 25. So that would be easier for you to reduce anything that you could diagonally or up and down, and then you can multiply your numerators and multiply the denominators. That's not really a new concept, but in this lesson, we're introduced to negative signs as well. So pay attention to that. Two negatives multiplied together will equal a positive. Okay. Number 6 asks us to compare these numbers. Now, I know that 3 is more than 0, but when we deal with negative numbers, the bigger the negative, the smaller it actually is. Think about how these numbers appear on a number line. As you move to the right, okay, those numbers increase. But as you move to the left into the negative numbers, those numbers are actually smaller. Think about money and debt. If you owed someone $3, okay, that means you have none. You're in debt. But 0 would mean that you're at a break-even point. Whereas if you have $3, that's more. That's a positive amount. So 0 is actually greater than -3. Be careful here because many would say that 45 is bigger than 15. And a positive 45 is bigger than a positive 15, but a negative 45 is less than -15. So the bigger the negative, the smaller that number actually is. All right, number 7, we're going to take a look at absolute value. The absolute value of any number is always a positive number. When we talk about absolute value, we really describe that as the distance that number is away from 0 on the number line. So I'm just going to take this middle one for example. If I was calculating, let's say, the absolute value of 4, that means what is the distance between 0 and 4? And I could count that's 1, 2, 3, 4 units. Okay? Well, if I'm going in the negative direction to -4, what is the distance from 0 to -4? And I count 1, 2, 3, 4. Distance is always a positive amount, whether you're driving forward, okay, or whether you're driving in reverse. Your car's odometer is still ticking forward positive amounts. So a positive direction or a negative direction is still moving a positive distance. Distance is never negative. So the absolute value of a positive number, right, is a positive 4. The absolute value of -4 would be a positive 4 as well. The absolute value of -2 is 2. That's the distance -2 is away from 0 on the number line. One thing to watch for here is notice that there's a negative sign in front of this absolute value. So the absolute value of -6 is a positive 6, but because that negative is out front, you've got to bring that down in your final answer. So watch out for a problem like that. Okay? All right, so number 8 asks us to find the quotient of the following. Remember, quotient is the answer to a division problem. So I've got -18 divided by -3. Well, of course, 18 divided by 3 is 6. I just have to decide, is this answer going to be positive or negative? The rules for division are actually the same as when we multiply. If you have an even number of negatives that you're dividing, then your answer will be a positive. If you have an odd number of negatives that you're dividing, like -18 divided by a positive 3, then that would produce a negative answer. So when we multiply, negative times a negative, I get a positive. When I divide a negative by a negative, I get a positive. If I multiply, let's say, a positive times a negative, I'll get a negative answer. If I divide a negative by a positive, I get a negative. It doesn't matter if that negative's on top or bottom. There's one of them, so that gives me a negative answer. Be real careful about this one right here. You're going to maybe see a problem like this week. I'm wanting to know the quotient of -18 and 0. It's impossible to divide by 0 in math. It's just not defined. I can type -18 divided by 0 in my calculator, and it's going to give me an error, a divide by 0 error. It's not possible to do that. So when 0 is on the bottom, we answer that with undefined. You don't need to simplify that all the way. Whereas this one is a little different. 0 divided by 3, any 0 divided by anything would always be 0. But be watchful for this one. If 0's in the denominator, if that's my divisor, it's undefined. Okay. All right, next thing we're going to talk about is scientific notation. This is a way that we write really big numbers or really small numbers. Scientific notation comes in the form of a times 10 to some power, where a is a number between 1 and 10. A can be equal to 1, but it has to be less than 10. So a is greater than or equal to 1, but it has to be less than 10. And n represents any integer, okay? So this right here is a really small decimal. So what I want to do is to rewrite it in the form of scientific notation. So I'm going to move that decimal over until I get a number between 1 and 10. 397 is too big, but if I stop right here behind that 3, I get the number 3.97. Include all of those non-zero numbers in that decimal. Okay, now I'm going to multiply that times 10 to a certain power. However many spaces I move that decimal, 1, 2, 3, 4, 5. And because that was a really small number, my exponent will be negative. Whereas here I've got a really large number, that's 12,345,000. So I'm going to take my decimal that's understood to be at the back and shift that over until I get a number between 1 and 10. Like 12 is too big, so I've got to go one more time. So that number will be 1.2345. That's between 1 and 10. Multiplying it by 10 to some power. However many spaces I move that decimal, that's my exponent. So 1, 2, 3, 4, 5, 6, 7 times. That's a positive exponent because I had a really big number. So when I'm shifting my decimal to the right, because that decimal is really small, I get a negative exponent. Shifting that decimal to the left because my number is really big, that's a positive exponent. All right, number 10, this is in scientific notation, and it asks me to give it in decimal notation or standard notation, it may say. So what I'm going to do is take that decimal, it's a positive, times 10 to the 5th power. If you're multiplying by any powers of 10, your number is going to get bigger. Whereas this is really more like dividing by 10. I know it says 10 times 10 to the negative 5 power, but that's the same as dividing by powers of 10. So because this is a positive exponent, it's going to be a big number. I'm going to shift it 1, 2, 3, 4, 5 spaces, and I'm going to fill in those empty spots with zeros. Don't just add 5 zeros to the back of that number because I had to go across that 4. That leaves 1, 2, 3, 4 spots left over. So my number is 2, 4, and 4 zeros behind it, so that would be 240,000. That's the standard notation for that number. So be able to go from your number to scientific notation or from scientific notation to your actual number. Okay, 11 says to find the temperature after a rise of 18 degrees from negative 22. So if you're at negative 22 degrees and you're adding 18 degrees, remember you're moving to 0 in the positive direction. My signs are different, so I'm going to subtract these numbers. Okay, and then I'll take the sign of the larger number since 22 is greater. That's still going to be in the negative. I didn't make it to 0, didn't make it to the origin, and I didn't get in the positives yet, so I'm at negative 4 degrees after a rise of 18 degrees. If anybody has any questions, don't hesitate to jump in here as I work. All right, we'll look at a couple of word problems. Number 12 says, to discourage guessing on a multiple choice exam, an instructor graded the test by giving 3 points for a correct answer, -1 point for an answer left blank, and -2 points for an incorrect answer. How many points did a student score who answered 38 right, 4 incorrect, and left 8 questions blank? So here's what I know. Those 38 points that were correct, she got 3 points apiece for those, plus the 4 questions that were incorrect, counted off 2 points each, plus the 8 questions left blank were 1 point, counted off each. So I'm going to do my multiplication. 38 times 3 is 114. 4 times negative 2 is a negative 8. And 8 times negative 1 is a negative 8. So 114 minus 8 minus 8, essentially what you're going to do, and that's going to equal a 98 for that score on that test. Okay? Because remember, adding a negative, you're taking away. Okay? So 114 minus 8 minus 8. All right, one more from chapter 10. It says the boiling point of mercury is 356.58 degrees Celsius. The melting point of mercury is negative 38.87 degrees Celsius. Find the difference between the boiling point and the melting point of mercury. So if I'm finding the difference, that means I'm going to subtract them. But notice I'm subtracting an already negative. So we talked about that, how that's the same as adding the opposite, okay? So I like to call that leave, change, opposite. We're adding the opposite sign. 2 negatives make a positive when they're back to back like that. So, so not only like is this 356.58 degrees away from 0, but then I've got to also add the distance from 0 to this number right here. So as I add these together, that's going to give me 395.45 degrees. That is the difference between those two temperatures. Okay, so those are just some examples from chapter 10 relating to rational numbers, and hopefully those will be helpful as you do your apply this week. Now chapter 11 begins some algebra topics. So these you may need a little more practice with, or maybe you enjoyed algebra in school, so this might be something that's easier for you this week. Either way, don't hesitate to contact me by text or email if you've got some questions as you begin to work your lesson. So notice, according to order of operations, I would try to simplify anything inside this parentheses if possible, but you can't subtract A and B. They're not like terms. A like term has the same variable with the same exponent. But I can multiply anything together. So by simplifying, I'm actually going to use the distributive property and multiply -2 times each term inside that parentheses. So that'll be -2 times A, and then a negative, I think of that as a negative B, so a negative times a negative would become a positive 2B. Now I cannot add those together because A and B are not the same variable, but that's how I can simplify using the distributive property. I'll provide another one like that. So, okay. So I can't subtract 2x minus 4 because those are not like terms, but I can multiply anything. So 3 times 2x would be 6x, and 3 times -4 would be a -12, and that would be your final answer. So be careful using the distributive property. Number 2 ask, is -2 a solution for this equation? Solution is another word for answer. What that's saying is, does x equal -2? That's a question. So to check this, I can substitute -2 into the place of x, and I want to see, does the left side equal the right side? Well, 3 times -2 is -6. And if I subtract 2, that's the same as adding the opposite. Those are both negative, so they have the same sign. That will produce an answer of -8. Excuse me, that actually was a -8 there. So yes, these left side and the right side will equal each other. So I'll just answer with a yes. So I'm substituting -2 into the place of x. And I want to see, does it equal -8? And so I just simplified that down to see if it does. All right, several problems are going to ask us to solve for the variable. That means I want to isolate x. I want to get x on the side by itself so that when I'm done, x is the only letter or only term left on one side and my answer will be on the other. So to undo -3, we do the opposite. Okay, Instead of minus 3, I'm going to add 3 because that will make 0. But whatever you do to one side, you have to do to the other. So negative 7 plus 3 would be a negative 4. So my answer is x equals negative 4. You can always check that by substituting it back into the original problem. Negative 4 minus 3 is negative 7, and so that would check out. All right, number 4 is a two-step equation. I always tell my students to save the number with the letter for last because you're working backwards. X is multiplied by negative 2, then added to 5 to get a negative 9. So when you solve an equation, you're working backwards. You're going to undo what's been done. So we're going to undo the plus 5 with a minus 5. So negative 2x, same signs, you're going to add and keep their sign. So that's a negative 14. Negative 2x equals negative 14. This is an understood multiplication between that number and that variable. So to undo multiplication, you would divide by a negative 2. That will cancel out and make 1x, which is what we want. But whatever we do to one side, we have to do to the other. So a negative 14 divided by a negative 2 will equal a positive 7, and that will be my answer. So when it says solve, you're trying to find what the variable equals, and you won't stop until you have x equals, or whatever your variable is. Number 5 is different because I'm not solving anything, I'm evaluating. I know that A is 2 and B is negative 3, so I can substitute those numbers into this problem in the place of those variables. And then I can use order of operations to work through that. 2 squared, 2 times 2 is 4. That's a negative 3 times a negative 3 would make a positive 9. And then 9 plus 4 will equal 13. Okay, so that one we just simplified after we substituted those numbers in the place of those variables. 6 is another solve, so I want to know what does x equal. X is being multiplied times negative 3, so the opposite of multiplication is division. You do that opposite operation. So 27 divided by negative 3 would be a negative 9. Okay, we're going to do several more of those equations, just looking at the different types. They get a little more complicated as we go. So when it says solve, I want to know what does x equal. So save the number in front of the variable for last. We're going to undo that plus 3 with a minus 3. That's how we take it off. So 2/3 times x equals negative 9 minus 3 would be a negative 12. All right, so in a problem like this, let me come over here. I have 2/3 times x equals negative 12. You know, if that was just 2 times x equals negative 12, that's a little bit easier. I just divide by 2 and I can get my answer. That would be negative 6. But typically when I'm dividing by a fraction, I can put that in the calculator wrong. Remember, when we divide by fractions, that is the same as multiplying by its reciprocal, okay? So when we divide with fractions, if you're going to use a calculator, make sure you put that fraction in parentheses. But dividing by a fraction is the same as multiplying by a reciprocal. And that would actually give me the answer negative 18. So what we can do instead is just to come right off of this problem, because a number times its reciprocal always equals 1. So if I multiply the right-hand side by 3/2 as well, that will still give me a negative 18. So you can work it either way. But remember, if you're using your calculator and you're dividing by the fraction 2/3, you have to put that in your parentheses. But dividing by a fraction is the same. Leave, change, flip. We call that multiply by the reciprocal instead. All right, notice the difference in number 7's problem and number 8. It says simplify. So I'm not going to get an answer like x equals something else. I just want to simplify this down to lowest terms. I can't subtract 2 from 3x, but I can distribute that negative 2 inside the parentheses. So don't forget to distribute the sign with that number. All right, so negative 2 times 3x would be a negative 6x. And negative 2 times a negative 2 would be a positive 4. The only thing left to do is to combine any like terms. Right here I have like terms. 3x take away 6x would be negative 3x, and I'll just bring down that plus 4 because those are not like terms. That's going to be my final answer. So distribute what you can. You can multiply anything together. Watch your signs. Two negatives make a positive, and then combine like terms. Make sure to follow your integer rules. 3 minus 6 would be a negative 3, and then I bring down that plus 4. All right, now we're back to solving. Notice in this next one, I've got a variable on both sides. So when you have a problem like this, when you should not have more than 2 terms on each side of your equation. If you do, it's going to require some simplifying, like we'll get into this next problem. But I have a variable on both sides, so we need to get those letters on a side together. I encourage my students to move the smaller one. Negative 3 is smaller than 6, so if I do the opposite and add 3, those cancel, and I do the same thing to the other side. So that makes 9x minus 9 equals 36. And then we'll work backwards to solve this. I'll begin by adding 9. So 9x equals 45. And the opposite of multiplication is division. So x equals 5. Remember, you can substitute that back into each side and see if the left side equals the right side to know if you got your answer correct. All right, the next one I'm still solving, but I got some cleaning up to do here. I need to distribute first. 3 times x is 3x, and that will be minus 6. And then I have a plus 2. So I need to combine like terms. I really should not have more than 2 terms on each side of my equation. So negative 6 plus 2 would be minus 4. And now we're just going to work backwards to solve this equation. So I'll undo the minus 4 with a plus 4. That cancels out. Whatever you do to one side, you do to the other. So 3x equals 11 plus 4 is 15. And the opposite of multiplication is division. So x equals 5. Okay. 11, it's not solving, it's simplifying. So in order to simplify, you want to combine like terms. Notice all of these have BC. They all have the same exponents as well. So we'll just work left to right. 6 minus 7 is negative 1. Plus 2 is positive 1. Minus 5 would be negative 4 BC. When you combine like terms, your exponents stay the same. So once again, 6 minus 7 is negative 1. Negative 1 plus 2 would be positive 1. And 1 minus 5 would give you a negative 4 BC. All right, so let's finish up with a few word problems. Number 12 says to find the Celsius temperature when the Fahrenheit temperature is 100 degrees. And this is the formula we're going to use. So they really just said F equals 100. That's what they've told us. So what I can do is substitute 100 into the place of F and solve this equation for C. If necessary, I want to round that to the nearest tenth place. So remember, save that number in front of the variable for last. So that means I'm going to undo this plus 32 by taking it away. All right, so that means 100 minus 32 would be 68. All right, I'm going to rewrite that 9/5 C equals 68. Remember, like we did before, you can divide by that fraction. Just make sure you put it in parentheses. Or remember, division is the same as multiplying by the reciprocal. So to make 9/5 cancel, I'm going to multiply by its reciprocal. See how those just cancel each other out? That leaves 1C. But whatever I do to one side, I have to do to the other. So 68 times 5 divided by 9. That's going to give me the decimal 37.777. That just keeps going. So I'm rounding to the nearest tenth place. The number right behind it is 5 or more. So we'll bump up the score. So my answer is going to be 37.8 degrees Celsius. So not only solve that equation, but make sure you round your answer to the correct decimal place. All right, just a few more. We're going to be translating some phrases. It says the total of N and the quotient of n and 5. We're going to translate that into a mathematical expression. I do not have to solve it. I'm just going to rewrite that problem. Remember, total means I'm adding something together. I'm adding n and the quotient of n and 5. Okay, so n plus quotient, right? So what am I doing with n and 5? Quotient is the answer to a division problem. So that means I'm dividing n and 5. I do not have to work that out in any way. I'm just rewriting that as a mathematical expression. So the total of n and the quotient of n and 5. Okay, just a few more like that. It says translate the sum of 5 more than a number and 1/3 of the number into a mathematical expression. So sum means add. So what am I adding? I'm adding 5 more than a number and 1/3 of that number. Okay, so here's what that's going to look like. 5 more than a number, so that's some number plus 5. 5 plus n is also acceptable because the commutative property works for addition. It does not work for subtraction. And I'm adding that with 1/3 of the number. Whatever letter I chose, that's the number we're talking about. So I'm adding that with 1/3 of the number. And that's my problem. Okay. I don't have to solve anything from there. I'm just translating that from words into an expression. 15 says the difference between 9 and twice a number is 5. Find the number. Okay, so I'm actually going to solve this one. Remember, is means equals, of means multiply. So here I've got an equation. Difference means subtract. So what am I subtracting? 9 and twice the number. So 9 minus twice a number. Twice means 2 times. Pick whatever variable you want. Is means equals, it equals 5. So the difference between 9 and twice the number. Remember, subtraction is not commutative, so you could not rewrite this as 2n minus 9. It wouldn't give you the same answer. But this equals 5. So we're going to solve this like we did the others. This is a positive 9, so I'm going to take it away from both sides. So that leaves negative 2n equal to 5 minus 9 is negative 4. And then we'll divide both sides by a negative 2. Remember, a negative divided by a negative would end up being a positive 2. So be able to translate that into an expression, and then if necessary, you'll be asked to solve that problem. All right, here's another. The product of 5 and a number is 50. Remember, product means to multiply. Is means equal. So I'm multiplying 5 and a number. So 5 times some number is 50. So I can write that as like 5n equals 50 because a number and a letter right beside each other, that's the symbol that it's understood to be multiplication. So if I divide both sides by 5, I will get 10. That's the answer to this problem. All right, one final one. It says a tablet PC is on sale for $392. This is 80% of the regular price. So find the regular price of the tablet PC. All right, if you look through the lesson, I think it's going to show you how to do an original change in new setup. So we've got the original price, a change in price, and then a new price. So I'm just going to make a ratio box to help me organize my information. When you buy something, if it's not on sale, you're going to pay 100% of that cost. That's just the basic. But this is 80% off. 80%. You're going to pay 80%. So my new price is 80% of that regular price, which means that there has been a discount of 20%. All right. So the price I'm paying, the sale price, is that new price at the register. Now the question is, what was the regular price? What was the original price of that item? Now, I don't know what that is, but I can take this information and set up a proportion to try to find that. So 100 over 80 equals x over 392. We can solve a proportion by cross multiplying. So 80 times x equals 392 times 100, and then I'll divide both sides by 80 to find my answer. So X would equal, when I do that math, that's $490, okay? This is not the only way that maybe you would have chosen to work this problem, but it seems like the problem on the apply this week, it might be beneficial to set it up in this ratio box with the original change in new concept. So you might want to look at some examples from chapter 11 related to that. Our code word this week is going to be solution. So if you're watching this at a later time, make sure to email me a brief summary and include that code word solution to get your extra credit. Thanks everyone for participating tonight. I hope this has been helpful.